Chapter 1. In Chapter 1 we talk about partial derivatives. And these can be written as df by dx or df by dy, or sometimes with the index fx and fy. And taking the partial derivatives, we can define something like a gradient, which we use the upside down triangle. And this is a vector made out of the derivatives. So vector df by dx, df by dy, df by dz. The Laplacian is another important quantity, which is the triangle the right way up. Laplace f is then the sum of the second order derivatives. D square f by dx square plus d square f by dy square plus d square f by dz square. Then we encountered three kingdoms of partial differential equations. The elliptic kingdom, and the ruler is the Laplace equation, Laplace u is 0. And then we have the parabolic kingdom, where the ruler is the heat equation or the diffusion equation, ut equals Laplace u. And then we had the hyperbolic kingdom, where the ruler is utt equals Laplace u. And of course, this is the wave equation. And in the course, we will work with all classes of equations and learn how to solve them. Each PDE needs side conditions, and these side conditions have different types. They can be initial conditions or they can be boundary conditions. And we had a rule of thumb which says that the number of side conditions equals the number of derivatives. So if you have two time derivatives, you have two initial conditions. Then different types of boundary conditions were Dirichlet boundary conditions, where we define a temperature at the boundary, for example 0. Then we had Neumann boundary conditions, where we define the flux on the boundary, and the flux is ux. So the x derivative on the boundary is given, for example 0. And then we can have Robin boundary conditions, which are mixed. They're of mixed type. So they involve u and they involve ux. And they can have different forms. Now finally, important to remember, a steady state is always a state which is not time dependent. No time dependence, which means the time derivative is equal to 0.